There's another interesting study that came out in 2010, which was an EEG study of desktop users done. Yeah.
Sorry.
Oh, sorry.
On the previous slide,
yeah.
Is that synchronous or is it asynchronous?
Is it, sorry?
The banner, is it asynchronous?
I don't know. I'm assuming that they basically artificially delayed it in the lab, so I don't think that whether it was async or not, it was.
Pretty sure it would be async, because the rest of the page was be drawn already, and the banner is slowly drawing asynchronously to the rest of the page, and the user is busy looking around the page waiting for the banner to come in. So I'm pretty sure that banner there would be in the experimenters constructed it, but they probably just put it in an iframe and then delayed the iframe is likely how they would do that. So it would be fully async to the page. But definitely in this study, you're going to see that the rest of the content which their eyes going around looking at is completely rendered while they're waiting for, in this case, the primary piece of content, which is very bad in terms of marketing, because your main message by the time they see it is they're probably just frustrated at this point, right?
So if you've ever sat in on a marketing meeting where everybody's agonizing over what to put in that banner area, and it's like, no, my thing has to go there, no, my thing, and people are kind of really duking it out over who owns that space. If you're not even accelerating that space, if you're not optimizing that space, then it's all kind of a futile effort, almost.
When we talk about one of the techniques is asynchronously loading content that's slow, there's a lot of anti-patterns, right? It might be a great idea in terms of getting content on the screen to load it asynchronously, but in terms of psychology of the user, you might have lost them if the main message is the thing that's async and it's coming in later. That by the time that it does come in and you've rendered the page quicker, in 2 seconds maybe the text below has come in, but the user's frustrated because the thing they want to see hasn't appeared yet. Again, that's the subject of our talk coming up. I know about this only because we're starting to learn more and more about what users prefer. They're ruthless, by the way, users.
So this was a really, really fascinating study. I recommend anybody download it. It's a few years old, but it's still really interesting, and it's inspired us to do kind of our own research and follow this path a little bit more, where they just did a study of desktop users, hooked them up to EEG devices, throttled their connections, it took them from a 5 megabyte connection to 2 megs, and they found that concentration spikes went up 50% higher than for the optimal, like kind of the baseline test group. And then afterwards, when they did exit interviews with these people, and the people didn't know they were part of a performance-related test. They thought that they were just doing regular kind of usability testing, brand testing. They reported really negative brand associations. So based on this, we did our own research last year, and this is the download link to find the report. And it's just like, well, does this carry over to mobile? Because one of the assumptions that I encounter a lot is, well, people just expect devices or expect sites to be slower on mobile. It's just the nature of the beast, and 4% of people throw them, but everybody else is really, really patient, and they just know it's not our fault, and et cetera, et cetera. And what we found is really interesting was that actually doing a similar version where we introduced an artificial 500 millisecond delay and served that to half of our testers, was that we found a 26% increase in frustration, or up to 26% increases in frustration. And we found that when these frustration increases were most likely to happen were during two of the most high stress points in a transaction process, which are browsing and checkout. So even on mobile, people, you might think that they're accustomed to waiting, and they might tell you, well, yeah, I guess I expect sites to be slow, but they're still experiencing stress. So being prepared for something to be slow doesn't do much to mitigate the actual stress of it being slow. And then we found that similarly, engagement, which is a positive emotion, you want people to feel engaged by what they're doing, engagement dropped with the 500 millisecond delay for most of the sites that we tested. And what was really interesting to me was we gave people exit interviews after the tests, and we just asked them what they thought, and we took all of the adjectives, the descriptive words that they gave us in the exit interviews about each of the sites, and we fed them into a word cloud generator. You see here that on the top left was the word cloud for one of our sites that was at regular speed, sort of optimal speed, and then on the bottom right is the word cloud for the slow version of that very same site. So everything else being equal, the only differentiator was speed. What was really interesting is you can see the words that jump out at you, and again, people didn't know that they thought it was just a regular kind of usability brand test. But the word slow jumps out at you. Basic, hard to navigate, complicated, all of those words. It's noteworthy that both word clouds have some negative words in them because people will always find negative things to say about a site. That's just the way we are. But the slow version of the site, not only did people just have more to say in general, that's why there's just so much more density of words. People just wanted to talk more about the slow site and just tell us what they thought about it. But the negative words, there's 3 times more negative words in the slow version than there are in the fast version. And what's really interesting to me is that when people encounter a slow site, they don't put their feelings about the slow site into a tidy little box. It says, these are my feelings about performance. It actually trickled over into their entire perception of the brand. Content, they thought it was boring. Visual design, they thought was tacky and confusing, and they found the navigation frustrating and hard to navigate. So to me, this is something to kind of take away. And if you talk with the designers, the content managers, the people who do editorial for your site, all of those people, they need to understand that performance affects them as well. It affects how everything that they work on is perceived.
Yeah, just imagine that for a second. If you're a designer, we slowed a site down by 1 second, and people changed their perception of your design. Mm-hmm. Okay, they said it was tacky. The exact same site, there was not a pixel different, mm-hmm. right? And I think that's hard for people to, imagine that's got to figure into if you're spending thousands of dollars on redesigning your site, and yet it's going to be 1 second slower, you're going to have these negative impressions about how you've designed it. And I think that's significant. Like if you're going to spend the money and you're going to take all that time to make it more usable, I think you have to factor performance into that usable. It's got to be a pretty high priority, in your list as to, if you could choose black and white and fast versus very colorful, maybe a little bit ornate and slow, it doesn't really matter how well you've designed this ornate thing if it's slower. People are going to naturally think it's worse. Mm-hmm. And that's something, put that in your thinking when you're doing that redesign. Mm-hmm.
And the thing to remember as well is that, maybe there are some exceptions, and I hope there are more than there were a few years ago, back when in my usability testing days. But so much of design and testing really happens in an ivory tower, where you're working with prototypes, everybody's working on kind of souped up computers, you do your usability testing in a really nice lab. Nobody's testing for performance. Nobody's actually putting users through their paces on a site that actually has kind of real world performance. And I think that's where we risk letting kind of users really the real user experience sort of slip through the cracks.
I wonder how many redesigns, which are actually very good redesigns, mm-hmm. when they finally go to production, turn out to be 1 or 2 seconds slower, mm-hmm. and actually we think the redesign is a failure when it's not. The redesign was the right thing, mm-hmm. it's just that we didn't maybe defer some JavaScript or actually make the site render faster, where we would have actually got all the results that we expected from our redesign. Mm-hmm. So, that's just really important point when you're going through this. I know lots of people are, redesigns are a regular occurrence. The question is, what are the factors? What are the motivating factors in that redesign? Sir, you had a question?
And Kent, you're primarily talking about the pretty face exterior of the site. Think about what this implies to the developers creating web services 2 more layers deep in the infrastructure. Yeah. And they get hostile when I tell them that I can't afford the response times to be any more than 75 milliseconds at peak.
Right.
Because it all adds up to, second, 2 seconds at the pretty face.
This is it. I think that you need to use this evidence. We're hoping that what the gift we're attempting to impart here is this data that you can take to these folks and say, look, this isn't my opinion. This is the effect. This is the world. This is the domain problem that we're dealing with. And really, a lot of this research is about surfacing this domain problem that wasn't completely intuitive. And now we're starting to see the effect. And we have to just make sure that makes it on our priority list. So more people are thinking that I've got 75 milliseconds, I've got 12 services, and if I'm waiting for 2 seconds for an authentication, that's not acceptable. I've got to think of some other way. Yes, sir?
One more point I'd like to add is on the back end, on the server side, we struggle to reduce a couple of 100 milliseconds. But then all that is so casually just thrown away at the front end with all the garbage out
Yes.
This is the problem. Every time I go back to the front end guys and I say, it took us 2 months to shave off 250 milliseconds.
Yeah.
And you just casually throw away 10,000 milliseconds. I'm performance testing core metrics.
Yeah.
I'm performance testing monitoring. I'm performance testing. When a home page loads, there's more junk running other than the site itself.
Yeah, I really, so, the point is well taken. Back-end developers are often very familiar with the profiler. These are tools that have been around for 10 or 12 years. How many of them can read a waterfall? Garbage collection in JavaScript has a new name or a new theme when I think about it. We got to collect the scripts that are blocking and essentially creating these delays, which are in essence unacceptable. They're basically ruining our user experience, and we just have to make sure that it makes it in the priority list. That's the main point of this whole session, is to let's make sure that performance gets the priority that your organization needs it to have, your users need it to have. It's and it's no longer just an opinion. That we're now seeing that there's a lot to back this up, and it's just being naive to be hard on the back end developer and then letting the front end developer kind of escape with one like button that blocks and takes forever, or like it's easy to screw it up. That's for sure. It takes diligence to get it right, and we need that from the back end developers and the front end developers.
A way to think of it is just thinking about who are all the people who touch a page from the moment that it's conceived of till it actually goes live. And every single one of those people should know everything. Rather than put it in negative terms, think what are all the things that I can do as a content developer, as an image creator, as anybody who touches this page. What are the things that I can do to optimize performance and do my part, and actually see it as a bit of a handing off, so that it doesn't turn into this terrible band-aid sort of situation that so many people end up in.
I hope as we go through this, you'll see that actually normally the problem is more with the front-end developer in the long run. It's so easy to make a mistake of 100 milliseconds, or 1,000 milliseconds in the front end. Whereas normally, it's actually easier to test the back end too and get an average load time or an average response time. Seems like we've been focusing on it for a long time, and we just need to bring everybody in it's a whole product attitude. That's the whole site, the whole page, the whole experience we have to think about.
Okay, so just, it's funny, we were just talking about this. So just talking about page size, because this is something that I pay attention to. I read the HTTP archive kind of like it's my monthly magazine. And if you're not familiar with it, it's this really great repository of just data around 1 million websites, and you can filter it to the top 1,000, the top 100, and actually, see, and you can slice and dice the data in a lot of different ways, but you can see how big pages are, what resources, how that size is allocated to different resources, how things have changed. You can search it all the way back to when it was first conceived in 2011, I don't know. But anyways, it goes way back. It's a really, really, really great resource for this kind of historical data. And so just to clarify, the 2014 numbers that I cite there, that comes from the HTTP archive. The 1995 and 2010 numbers come from other repositories. But in 1995, think about the fact that the average page was 14.1 kilobytes in size and contained 2.3 objects. So really more like some had 2, some had 3. So 2 or 3 objects, HTML, an image, and maybe a second image. And that was 1995. It was a very simple time. 2010, we saw a typical page was, kind of 498 kilobytes, 75 objects. It was like, at the time, it was like, wow, that's like half a meg. That's pretty big. And we were like, could a page get to be 1 meg in size? Could that really happen? And then in 2011 or 12, that did happen, and we wrote a blog post about it, like, oh my God, the average page is 1 megabyte in size. And people were like aghast, like, no, it can't be possible. But it is possible, and what's more possible is that we're going to get to 2 megs really, really soon. And that's just because pages are growing, not exponentially, but definitely on a really steep curve. And if we look at our numbers, this is from our own study of the top 100 sites. In just 1 year, from 2013 to 2014, the median page has grown by 67% in total size. So in the summer, we found the median page that we tested was almost 1,700 kilobytes. So that's pretty huge. And this again comes from the HTTP archive. We see that about half of that is images. Really, it's up to 60% depending on how you look at the data. But just know that conservatively, on a typical page, about half the content is images. Oh yeah.
But most of the times, now in browsers, you still have you can offload your images to local cache.
Mm-hmm.
So a lot of times, once you visit the site, and people don't store their images as often,
Mm-hmm.
so you could still be just viewing locally cached images rather than going out. So there could be a discrepancy depending on multiple site visits after the first one. So that assumes a fresh, uncached copy.
Yeah.
I'm pretty sure the archive goes through and diagnoses when the headers are on the images to cache them. And so this would represent, if you had a repeat view, we would still know the content types of the subordinate resources or the sub-resources. So I'm pretty sure this is accurate even on repeat views. Sadly, not as many people as we'd like to see use cache headers effectively, and you get a lot of repeat downloads. Somebody was making a comment. There was a live stream of the largest software company in the world who had mistakenly removed their cache headers, and that resulted in a disaster, basically for their launch, because of no cache headers and not having that repeated. So certainly that's the largest payload. They're normally static. They're normally cached. And we want that, and we've seen if that ever goes away, the largest payload all of a sudden has to be re-downloaded, and it really turns out to be a big problem.
All right. I just realized we have a lot of slides to get through.
I know, you love slides.
I do love slides.
I'll go through my stuff quick.
Okay. So this is just kind of further to what I said earlier, which is that this is looking at the most recent HTTP archive data for all the sites that it gathers data from, and we see that we're creeping really close to that 1 megabyte page size. And here you see that images are much more than half. And then this is, I don't know if you can read this in the back, this is Jason Goldberg. He's a really great person to follow if you're into e-commerce. He writes about performance as well. But he was at a conference where, we see, we've got these massive images. Images are everywhere. They're, dominating, the total page size. And he saw a UX lead recommending using the largest images possible in responsive web design and just letting the browser take care of it. So this is sort of the stuff that you're up against. So I'm going to skip that. This is meant to illustrate pages and the web browser, the internet in general. So we're going to talk about third-party scripts, and we've sort of touched on it already. This is actually a stat from a talk that Steve gave a while back. Just the third-party calls can make up to more than 50% of page requests. So this is quite a change from a few years ago when maybe there were 5 or 6 scripts on a page. Now, I see pages where I use a tool called Ghostery that lets you see all the third-party scripts on any page that you go on. It pops it up in a little flyout. It's a really cool little tool. It's kind of scary because you go to especially media sites, and like the little flyout is like the entire height of your monitor. So these.
The name of the tool again is
Ghostery. Ghostery. It's just a little widget that you put on. I think it's only available for Chrome. It's not? Okay. Oh, okay, cool. So yeah, so Chrome and also possibly Firefox as well. And third-party calls represent the single greatest potential point of failure for web pages. They do a bunch of things. They increase your page weight, they increase the number of connections, they introduce latency, and they can even compromise user security and privacy. But the most, kind of deadly thing for our purposes is that, we've seen countless case studies, and I'm not going to call it any particular providers on this because it's happened to all of them, but they can prevent pages from loading completely if improperly implemented. And this is some data from New Relic. It's a little dated, but they did a study of a number of third-party APIs, and they gathered a lot of data and found that the response time for these particular APIs for their test ranged from like 800 milliseconds to almost 1800 milliseconds. And then there's something we call fourth-party calls, which are, there's a whole blog post that we wrote about them on Web Performance Today. So if you go to webperformancetoday.com and do a search for fourth-party calls, it'll go into that in a lot more detail. The URL is at the bottom of this slide. And really what a fourth-party call is when you install a third-party script. Maybe you can help me clarify what I mean here, because
you go and I'll just try to. You go.
Okay, and that script actually starts making a ton of calls to another provider, and so just by virtue of you installing this third-party script on your site, and it's common with like tracking beacons and things like that. You trigger this cascade effect of fourth-party calls, and on this particular waterfall, all of those red dots indicate fourth-party calls. So basically, calls that are not authorized by you, they're happening and gathering data, that sort of thing. There's a sort of a paranoid camp that just says like, oh, unsecure. It's really more of a performance risk than a security risk. At least for the purposes of our conversation, we should focus on that because each one of these fourth-party calls is generally happening over a secure line. So it's introducing some additional SSL kind of related slowdowns, and adding just a significant amount of latency to the page overall.
So in this case, we're calling to a third party, and then that third party is calling to a fourth and putting that JavaScript into the DOM and executing it, and then that JavaScript is then calling normally to another beacon or another site. If you look at how ads are fulfilled, often you'll see a lot of this. It'll call to the ad service, it sends all of your information, and it asks the first company that do you have an ad for Kent? And no, I sell tennis gear. Kent is a terrible tennis player. He doesn't look for tennis stuff. And then he goes to the guitar site and it sees, oh, I think I'll service, and I actually get an ad back. I can go 3, 4, 5 different 4 or 5 different services before somebody decides that they're going to fulfill my ad. So often if we look at a waterfall, and we'll talk more about this is a waterfall that we're looking at, we'll have the same site with the same user even have, you'll have 40 round trips the first time you look at the page and 120 round trips because you got different ads or different fourth party calls were put into the DOM. They made additional calls and you ended up with far more resource downloads. So when we talked about how you're designing the site and considering your own performance, Now imagine it has nothing to do with you. Maybe the marketing department has decided they want to use some ad service, and that ad service may not even be aware that they've acquired a new advertiser, and that new advertiser is using very limited compute in Amazon or something, and they get a burst, and all of a sudden a third party is actually all responsible for your page draw time going from 2 seconds to 8 or 9 seconds. And it happens overnight. You tested one day, it was fine. The next day, it's not. Or you tested as one user and it was okay. You test as another user and it's different. So it really, this third-party problem is very, very difficult for the FEO or the WPO industry. Trying to figure out a technique that works consistently and meets the business expectations is difficult. And it's very hard to design for. Imagine that we just talked about 1 second having such a big difference in your design, while choosing an advertiser and how that advertiser relates to other advertisers can actually have a huge effect on your site. So in case you thought it was going to be easy, it becomes more difficult to sort out the right decisions in this case.
Because your third-party ad providers probably don't want to be deferred. They want to, maybe they'll be happy to load asynchronously, but then it's all on you because they're probably not giving you an async version of their code. So, and asynchronous can be tricky. So it's a very complicated problem.
Yes, sir.
If you do make that ad provider an asynchronous call, would the fourth party also be implied asynchronous?
Yes, normally, depending on the technique. I'll talk a bit about the techniques, but if we throw them in an iframe, we are going to have they'll be installed into the DOM of the iframe, so it'll all be running asynchronous to your page. But depending on the site, that may or may not be advisable. Really what you want to do is take in your third parties carefully and keep an eye on them. That's part of the performance team, is to understand the response time of those third parties. And I'll talk about some techniques that you can use to try to rope them in and understand how to deal with the problems.
Okay. There's a really great tool. This one is definitely just for Chrome, called Spoff-O-Matic. It was developed by Pat Meenan, who also developed Web Page Test, and it works in conjunction with Web Page Test. So it actually lets you test for third-party spoffs on any site that you go to. So you just install the widget. There's a little icon on the corner for Spoff-O-Matic, and it lets you see, it identifies potential third-party risks on a page, and then it lets you run a few really quick and simple diagnostics with Web Page Test. So just as an example, I did this a while back just to show. So what it does is it basically artificially black holes the particular third-party script or all your third-party scripts, and then it shows you what the page render would look like if that content were black holed. So in this particular example, I generated a film strip view where you can see the original version of the page fully loaded in 3.5 seconds, started to render pretty early, at around the 2 second mark. And when we artificially black holed the third-party content, it just hung and hung and hung and hung, and then finally gave up and loaded at 22.7 seconds. So it's a great little tool. You can use it on your own site. You can use it on other people's sites. And I like the fact that it works in conjunction with Web Page Test. You can also generate a video view of the page render. And you can also call out individual sites and just test individual third-party providers and test what each of those would do.
We're down to 15 minutes left.
We're down to 15 minutes. Okay.
Just
all right.
So
Just quickly, third-party SLAs, service level agreements, are really great. This is an example of a good one on the Optimizely site. They go into kind of what you want to see in a third-party provider, they basically telling you the size of the snippet, how quickly it should load, that sort of thing, where it's hosted, and how they track it. So good stuff there. There's a link to it at the bottom.
Because I think it's going to be hard to get to everything, I'm going to answer the question.
Sure.
I'm so compelled to, this third-party scripts are just something that cannot be avoided. So there's really two basic techniques. One technique is to put it in an iframe. I know there was a time when iframes were shunned, but everything runs asynchronously. So if that third-party script doesn't interact with other parts of the DOM on the page, which we've found about 60% of them maybe don't interact, and you can actually just let that ad run in the iframe put in the same place. Well, at that point, your rest of your page, no matter what happens with the ad, it shows completely asynchronously to your page, doesn't affect anything else on it, which is a nice thing, right? Like most of the time. Again, if all of your revenue on your site is driven by advertising, then deferring everything and having it show up is sometimes not a good thing. So just this is a double-edged sword, because in that case, normally you want the page to show up just like a microsecond before the ad, and the ad actually has a very high priority. The advertiser always wants things to run synchronously, normally because they want more ad impressions. And the earlier in your page draw you put their tag, the more likely it'll fire before a person moves away. The other thing we experiment with is actually putting what we call a third-party SLA on a third-party tag. And essentially what we do there is we put a timer. We let it run in the DOM of the page. We put a timer and we'll say we give third parties 500 milliseconds to execute. And if after 500 milliseconds they have, we still haven't got a response, we'll just remove the tag from the DOM completely, which we find just lets the page render. And then we add it again after unload and say, okay, you get another try for whatever amount of time. And if the user happens to be still looking at the page, then they will get the ad. But that's a way that you can make your metrics more consistent. For me, as a performance engineer, third parties are a real plague, because if I was trying to give you mean values for my page draw times, and we have a page that has maybe from the origin 20 or 30 round trips, but the ads make it 40 round trips one time, 180 the next time, 60, and it's all over the map, well then my mean is and my metrics, even if I'm doing RUM on that site, become very hard to interpret. Right? Because actually what you're doing is just measuring the speed of your third parties, or maybe it has more to do with what users like tennis, and that you have a slow, the tennis ad has 20 resources being loaded into the DOM and things get really slow. So those are the two techniques that we are sort of, I want to say common, they're being explored a lot by folks in the performance community, and those are the ways to start dealing with the third-party problem.
So some other problems. This is a bit of a tongue-in-cheek thing. I work with designers a lot. I have worked with a lot of designers, and they're not idiots. They are hardworking people, and they're very good at what they do. So I don't want to disparage that. This is more to highlight certain practices that are great from a design perspective, or they're at least conventions from a design perspective. But then in kind of out in the wild, they cause performance problems. So one practice that we see a lot is pages being, and this all comes from our quarterly performance State of the Unions. Probably the most common problem that I see are pages that are completely blank, and then everything shows up in the browser all at once. Like literally everything, just boom at the very end. And then you can talk about when I go through these after, you can talk about what causes those problems, or the pages that load.
A horrible blocking script in the first one. Mm-hmm. There was some blocking script where everything else was loaded, but the DOM could not render the script, or the CSS the styles that were required for the very first part of the page at the top of the page weren't actually loaded until the 9-second mark in that case.
And then we've got pages where the nav elements load first, but the primary content loads last. And we already know from the Jacob Nielsen study why that's a really bad idea if you want eyeballs on your primary content. And so I've always interpreted this as basically just being about just page not being optimized properly, like the items aren't prioritized.
Yes, sadly, this is harder to fix most of the time, because often some back-end service, you're waiting for an authentication to figure out what part of what type of the user is coming in. I need to look at what they had last time. Mm-hmm. So This is normally caused by the fact that whoever is designing it is not prioritizing the content, and it's not always fixable in a simple form. Like now you're looking at what's the ultimate speed of your page, and I would look at dividing the page into smaller components to get something of your main content on the page earlier.
Another one is, call to action in marketing speak is probably the most important thing on the page. If the person who comes to your site does nothing else, this is what you want them to do. Click on the call to action. So something that I see, and it's more of a design convention than anything else, is that just the call to action being the very last thing to render. So you have this baseline image that's loading line by line. The call to action, it's coupon code, whatever it is at the very, very bottom of the graphic. So to me, that's a design issue more than anything else. I don't understand why call to actions are always at the bottom. Oh, there's a question way at the back. No.
But I will ask away.
So in the previous slide, you mentioned primary content. I think when you were talking about Jacob Nielsen, you mentioned that you saw spikes in user frustration. How are you measuring that? Like, is it just overall conversion rate? What's your measurement for that?
How did Jacob Nielsen measure that when the primary content came in later that it was worse?
Well, he in that case he didn't actually measure for conversions because he was, it was a lab setting, so you can tell people to click on a button and they'll just click it. It was just a pure and simple eye tracking study, so just seeing where people's eyes went on the page.
Eye tracking. We also put, there's only a few ways that we can really test now. The stress test with the EEG helmet seems to be the most effective. In that case, you get a rise in stress when people aren't seeing what they want. The classic problem with the last one was a big flash. The call to action being in a big flash file, and that taking longest to download instead of actually breaking it up and optimizing the images so that they'll all appear fastest.
Differentiate what call to action or what the difference is between call to action and primary content design?
Sure.
Yeah,
So
you
sorry.
can go for it.
So the primary content is this entire image. It's basically it's that feature image that you want people to look at. The call to action is always a button or a link, usually on that page. And so in this case, God, I can't even read it. It's down here and it says. Okay, I can't even see. It basically is telling people to. I remember when I created these slides. It's telling people to click here to get a promo code to get to get a certain deal. So assuming you want people to actually use the promo code and start buying, then that's a really important piece of content. And again, this is more of a design issue than a performance issue, but it affects performance, or the two speak to each other. It should just be bigger and ideally more prominent higher up on the page.
And somehow not wrapped into the the major part of the image, whether that's one single hot map or a flash file. It could be separate images where you purposely loaded the call to action earlier.
And then another thing that I see a lot are pop-ups that block the rest of the page from rendering. And it literally looks like that last frame where the page is partially rendered. Before it even goes any further, the pop-up shows up. And then the pop-up takes, you're waiting a few seconds for the pop-up to render. And often this all happens within the first few seconds of being on the page. And often the pop-up is asking me, it's some call to action that I haven't even decided I want to use yet because I haven't interacted with the site enough to know that I'm even on the right page, that sort of thing. So, to me, you can fix this by delaying the pop-up, by optimizing the pop-up.
Putting the pop-up in the content in an iframe, or you just have to get the pop-up to render asynchronously to the rest of the page. That's really critical. I myself question using a pop-up that early in a site in the first place, but that I think is we know from our studies of the human brain that the more multi-phase rendering you do, the worse it is for your users. Your brain wants easy. Yeah. Your brain has the biggest easy button in the world. As much as you like to think you're a rigorous thinker, your brain will, if it can put something together quickly, it'll do that whether you like it or not. So if you continuously introduce multi-phase approaches to things, you'll find that a lot of users just tire and they don't actually get what you're trying to give them. Okay, they actually, their brain has given up, they've moved on psychologically at that point.
And the other funky thing about these pop-ups is how often the pop-up finally renders, but actually it blocks the rest of the page. So the page isn't rendering behind it. It's just sitting there, and then you close the pop-up, and then the page finishes rendering. So that seems to me like a fixable problem as well.
Yeah, a lot of, as we're going through this, like we talked about 3 seconds being the tipping point. If all these things that we're trying to fix, it's like trying to fix a mistake after the mistake has been made. What we really want to do is have the whole page render in 3 seconds or less. And the more complicated we make that, the more we have to have one thing and then another, the worse our impressions will be, the worse our page ultimately is for our users. Imagine the best is to have it like a piece of paper. You're looking at a magazine and it just appears, and that actually what you've designed and the content draws the eye and draws the user. When the more, as fancy as I like to be in WPO, the more complicated we are, the more multi-phase we are, we know that is harder. The users start to tune out, and that you're asking the user has to be, you're asking for more engagement, and unfortunately, you just don't get engagement for free. That engagement is something you get, like respect. It's not something that is just automatic.
So I first want to mention that it is 10:29 right now, and we have like 10 more slides. That's my fault. I didn't think we would get so swept away by wanting to elaborate on so many of the points. So maybe we'll go for another 5 minutes or so, and then Kent and I do have an office hour tomorrow afternoon, so we will field all questions wherever the office hours are happening, somewhere around here. And so yeah, let's do like 5 more minutes. So I'm gonna let you take over. You can talk about it.
Oh, right.
Yeah.
The sidekick comes in. I'm still looking for my sidekick name. I don't want to say what your sidekick or your superhero name is.
Yeah, I've got it down to 2.
You got it down to 2.
Yeah.
Okay. I'm just going to go right to what I think is the most important. Mm-hmm. So the goal here was to give you guys some background for all the stuff that you're going to learn in the next 2 days. And this has been very much a why do you need to learn this stuff? Right up to this point, why do you need to learn this stuff? Why is it important? And like you saw, there was hands that went up. There's people trying to convince others that performance is important. So I'm going to skip over to more of a developer mindset and talk about first waterfalls. This is a waterfall. Most tools in browsers have waterfalls. If you're thinking of a profiler, if anybody writes code and they're concerned with performance, they will have looked at many different profiles in their lifetime. It's very common that we do this. In front-end performance, contrary to back-end performance where you're making a 75 millisecond call in the back end and you're using some profiler going through lines of code, figuring out which function actually took the most time or is blocking. This is a waterfall that every front-end developer must be able to read. This is like reading English, for somebody that's coming to America. It's an important thing, right? There's signs. You have to know what's going on in terms of a waterfall. And in this case, it's essentially the HTML page is at 1. The HTML page gets fully, we download the HTML page, and then all of the subordinate resources are loaded as the DOM processes and creates all of the images and places it on the page itself as it's rendering. We see lines. I'm going to show you a detailed view of this, where we start to render, where we have doc complete. You can look. These are all the URLs, and let's go to a larger version of that.
There you go. That one?
Yeah, I think that's so. Each URL, if there was a third-party URL, I'd be able to clearly see that's not an URL coming from my domain, which would be listed here. There's a line that says start render. This is when I'm starting to see something on the screen for the user. Doc complete, that's when the JavaScript doc complete fires, so I can now do stuff after the page is fully rendered. and fully loaded. I've now finished loading all the things on the page, and the browser isn't making any more requests. Can you skip one more down? So each line will show you the DNS lookup time, the connection time. Now we're looking at time to first byte, and then the load time for the content here. So this allows us, imagine many times I've gone to a client site to find out, hey, our site was 2 seconds, now it's 4.5. And there's a notion that we've talked to all the back-end developers. They're really sort of aggressive about looking at their own organization first, which is, most developers, by the way, when I say your pages are slow, the first thing they do is look at their own code. It's almost all, time to first byte, server-side generation time. And as a gentleman brought up a little while ago, he spends all the time getting shaving 100 milliseconds off, and most of the time we see that the server-side load time makes up 20% or less of the full page load, okay? So most of the time, the problem is after we get the HTML down to the client, the server has done everything it's supposed to do. It's fully generated the HTML, and now we're loading all of the resources to render the page. Often I see, DNS, somebody's changed a DNS server, or the DNS service itself has gotten slow, and all of a sudden I look at these lines and it has nothing to do with the page, nothing to do with the organization whatsoever. They're using a third-party DNS for whatever reason has changed and is now it was responding in 60 milliseconds, now it's responding in 250 milliseconds, and that radically changes the waterfall. So just like using, measure first. Don't change your code first. Don't start deferring stuff or doing, changing your images or any of that, okay? Start by looking at a waterfall and finding out where your problems are, right? Just like if you're profiling. I've been to many places where, you walk in and the developers say, well, I know where the problem is. I'll just fix the problem. I say, I've got a really long running database query, and they won't use that profiler to find out, let's use evidence. Let's look at the facts. And this, to me, is the facts in front-end performance. So this is like the 101. You need to learn to read a waterfall, be really comfortable with it. Each of the browsers has their own tool built in. IE now has a really nice one. Chrome has always been really great. Safari has one. Much more difficult to get one in mobile, okay? You can, we're starting to find that the new web page test components are great. We can start to see waterfalls, but the main message is in all the sessions you're going to find in performance, they're going to teach us how to change that waterfall, okay? And you'll see me watching just as captivated as you guys. I'm always looking for how can I manipulate that waterfall to our benefit, to our users' benefit, okay? So I think that's the major takeaway here is to learn to read waterfalls, learn to use them in your daily work. I see you, Steve. I see you, and I raise you. A closing remark. Okay, so when you look at changing waterfalls, you look at the techniques that you're going to see throughout the conference. You're going to see methods of reducing round trips. You can inline. You can take images and make them data URIs and put them in the HTML. You can take images and tile them. You can concatenate scripts. Find ways to reduce round trips. Okay? You can also, by the way, use a CDN to reduce the time it takes to download those things, which effectively works on the same problem. You can reduce the payload, create images that are the right size. You can use gzip in the right way. You can cache images so they don't repeatedly get downloaded. Those are all ways to lower the payload of the page that you're looking at. You can change the content order by bringing most notably the CSS to the top. You need all those selectors that are being called above the fold to be known in the DOM very, very early. And lastly, I think these are the major categories. You can defer execution. Most notably, you defer the execution of blocking JavaScript because it doesn't need to actually execute at the top of the page, or while the user's waiting for something, it can actually execute maybe after on load, where it's not affecting the user experience. So
we're going to just, everybody cover your eyes for a second. We're not going to be able to talk about mobile performance today, but if anyone has any questions, we can take a few questions.
Yeah, I encourage you guys to come to our office hours. This is a deep topic. We'd love to talk it over with you. And thanks very much for coming and taking in this session today. I hope this has helped you.